Hi everyone, this is medium level problem solving for biweekly contest 137. So this is the problem number one, find the power of k size subarrays. So over here in this we'll be given one array nums of length n and one positive integer k. So what we have to do is we have to find the power of all the subarrays of nums of size k. So the basic gist is once we traverse all these elements in the array, it has to satisfy this particular condition, this condition. The element we have to extract out the maximum element such that it is consecutive, sorted, and ascending order. So this is the solution for it. And So I went with the brute force approach for this one. If I look into the line number 5, so since we will be given integer k and we have to pass this nums element in the length of k subarrays and extract out the maximum element of these particular k length size subarrays. So this is the resultant array that I've declared with the length of array minus k plus 1 mm, because it will be so this is how many subarrays that we'll be getting out of nums if we have given the integer k. So now this is the index ported and I have used this flag whether to check whether we are satisfying this condition of the element whether they are in ascending order or not. So I went with a simple for loop to pass out all the elements in the array and use this nested loop to pass out all the subarrays to ensure this particular condition that we are just getting matched or not. So in this particular one, we have this condition where we are checking whether the elements that we are seeing are in consecutive order and also in ascending order. So by default, the sorted condition will be satisfied if these two conditions are satisfied. So once we are seeing these elements which are in consecutive order, we'll be incrementing the j, and once it is incremented, so we'll be keep on incremented. If it is not equal to it, we'll be uh, this using this not ascending order flag equal to true and then breaking out of this nested while loop, and based on this we'll be storing a result in our result array. So it's very straightforward brute force approach that I went with in order to do this. So it was completed. So it was not so hard. So and moving on to the next one, which is the main thing. So first I tried this, which is the same problem as the earlier one. The only difference is if we solve with the early brute force, you're gonna get TLE, but over here in this approach, if you can see there is a pattern involved over here, which is a sliding window pattern, which is what I have used over here. So starting from the top, if looking beyond the variable declarations, we have line number 8 is the edge case. So in this particular edge case, if in case the length of k is equal to 1, then we have to return the nums array. The reason for it, because if you'll be given the array of elements, and we from that array of elements we have to figure out a subarray and the maximum element out of it satisfying this particular condition, but the size of subarray is equal to 1, then every time for every element in that particular subarray the condition will be satisfied, so ultimately we'll be returning that nums array itself. So that's the edge case, and over here we have this condition. So this is the very first uh, traversal till the k length, which is the k length of the sliding window. So based on that first k length, we will be figuring out whether this particular uh, subarray of elements are in ascending order or not. So by default, the as async boolean variable is equal to 2. So we'll be checking whether it's not equal. If it is not, then it will be set it to false. So this is the main intention of it. So once I found out, we will be storing a result over here for the first one. And from next computation of it, which is starting from y is equal to 1. It will be running till num's length minus k plus 1. So which will be till over here, because k is equal to 3 and num over here is equal to 7. So the traversal will go till here. And in this one, since we'll be utilizing the answer that we got from the previous sliding window that we have computed for it, and from here we'll be doing the traversal. So for the first one, we'll be checking if you look from the line number 3. So utilizing the result from the previous sliding window, whether it was in ascending order or not, the earlier on the if it is. So the only thing that we have to check in order to reduce the number of computation is the incoming element and the outgoing element. If you look into this form, the outgoing element is 1 and the incoming element over here is 4. So, so we'll have to check only these two things, and that's it. And that you got the answer. So, given that the earlier answer was true, the earlier sliding window that we have computed is equal to 2. So, over here, the incoming number. So, first we will be check the outgoing number, which is 1 and 2. So, we did a comparison over here, minus 1, nums minus 1 over here, which is equal to 1, and then this one, the current I is equal to 2. So whether they are equal or not. If they are not equal, we will be setting it to the false. And but they are equal, so yeah, this condition is false. And then we have to check the outgoing, sorry, the incoming element, which is the 4, with the last element of the sliding window, which is 3. So which is done by this one, I plus k. So 1 plus k is equal to 3 will give us 0, 1, 2, 3, 4. So over here, so we'll be subtracting it minus 2. We're gonna go 2 steps back, we are at 3, and then 1 step back, we are at 4. So based on that, we'll be checking these two, incoming and outgoing element. And based on once the condition is ensured, so we can see plus 1 is equal to 1. So we'll checking they are consecutive and in ascending order. So it is true, then we're gonna go till here and store the result. Whether ascending is by default is equal to true only, and that's the reason why we got the answer over here is equal to 4 for the first iteration. And if we go over here 343, which is the next one, so the I will be incremented to the next count. And once we have the incremented count, and our earlier result was again true, so we're gonna go over here and check. So if we check for this particular one, so it will be satisfied. So I minus 1 plus 1 is equal to 3 and 3, which is equal to true. So this one true, good to go. And but if we check this particular condition, the incoming element over here 3, and if we did a comparison over here, so we will getting 4 plus 1 is equal to 5, and which is not equal to 3. So we'll be setting it to false. So if it is equal to false, we'll be storing minus 1. So this is the minus 1 result that got stored over here. And again, if we go with over here, the 3 to 5, again, now the negative case for if, what if the if is asec is equal to false, then we're gonna go over here. And then we have to traverse this whole sliding window to check whether we have this order condition satisfied or not, which is consecutive, sorted, and ascending order of the sequence of elements. So looking over here, we can see, so we'll be given the I is equal, so I will be equal to this particular element 0, 1, 2, 3, 4. The fourth particular one is third, and we're going to check this one with this. 3 and 4 check will be done. So whether they are equal or not, they are not equal. So once they are not equal, we're going to set it to false and break it out, because the first element is not equal, which is 3 and 2. So my mistake, it's 3 and 2, a check will be done. So we'll be doing the entire traversal of the sliding window just like that, the one that we did initially. So based on that, once it is checked, and then we have to satisfy. So this is like pretty much easy. If you like click this particular pattern of sliding window, you'll be able to do it. So this is all these two medium level problems that was solved for this bi-weekly contest 137. Thanks for watching.